Good morning. I'm Mr. Muhammad Baghdadi, math teacher. Today we will study factorizing by grouping. Factorizing by grouping. Now we start with how factorize by grouping. To factorize an algebraic expression made up of more than three terms, we notice that there is no HCF between the four terms, and it doesn't have any of the previous forms that we have learned before. Therefore, we try to make groups having an HCF. Means, firstly, we divide all four terms into groups. We take the first term 2ax plus ay together in one bracket, and 2bx plus by with together. Okay, then we take HCF between 2ax plus ay. We find a is HCF, then we take a as HCF, then we find in the bracket 2x plus y. Okay, in other terms, we will take b as HCF, b and b, we take b HCF, so the remainder will be 2x plus y. Okay, after we take HCF from first bracket and second bracket, we find the remainder 2x plus y is common with 2x plus y. Then we take another HCF is the whole bracket. 2x plus y is HCF, okay? And we take the remainder. Then we find 2x plus y. If we take it as HCF, we find the remainder will be a plus b plus b. Now we factorize the first algebraic expression 2ax plus ay plus 2bx plus by is factorized as 2x plus y multiply a plus b. Okay, we can divide. In this example, we take the first term with second term and the third with fourth. We can divide as we want. We can take first with fourth, first with third term and the second with fourth. I will show it to you. As I said, there is another way to regroup the expressions. The expression 2ax plus 2bx plus ay plus by, we can commutative. We take the first with third 2ax plus ay together and 2bx with by. We find in first term and the third term a is a common term, a and a, okay? Sorry, 2x is HCF with first 2x, and here is 2x. We take 2x as HCF. If we take 2x from first and second after commutative, we find the remainder here is a. We put in bracket plus we find b. Okay, where 2x is HCF from first and second terms, we find the remainder will be a and b, a plus b. In third and fourth, we find the common is y. We take y as HCF. Then the remainder will be a plus b. Then After we take the first HCF in first and second parts, we find the bracket A plus B is common with A plus B in second, okay? Then we take all bracket as HCF and we cancel this part and this part. We find the remainder here will be 2x and plus y. Then the factorize will be the same factors, okay? 2x plus y in first, plus multiply a plus b. Here, a plus b multiply 2x plus y, okay? We take some more examples to factorize by grouping. Example, factorize each of the following expression. Firstly, x power 3 plus 2x minus x minus 2. X power 3 plus 2x minus x minus 2. We take here the first with second together and the third with fourth together. Here, x power 3 plus 2x power 2. The HCF between them, highest common factor, will be x power 2. Now we take x power 2. From first term, if we take x power 2 from x power 3, it means x power 3 divided x power 2 will be x. The remainder will be x. Here, 2x power 2, if we take x power 2, the remainder will be 2, only 2. Then x power 2 multiply x plus 2. In other term, we take the negative sign or negative 1 as HCF. If we take negative, x will be positive and the 2 will be positive. So if we take negative outside the bracket, we find x plus 2. Then we find the common bracket will be x plus 2. We take x plus 2 together. X plus 2 as HCF and open bracket, we find x power 2 minus 1. If we take x plus 2 here and here, we find the remainder in first will be x power 2 minus 1. There is no numbers or letters outside the bracket. It means 1. X power 2 minus 1. Okay? X power 2 minus 1. This is the firstly part of factorize. But this bracket, we can factorize it again. Why? Because this bracket will be the difference between two squares, x power 2 minus 1. It will make two twins of brackets. X power 2 will be x and x. Negative will be plus and minus, or positive and negative. 1, the square root of 1 is 1, so it will put 1 and 1. In second example, 16x power 2 minus a power 2 plus 6ab minus 9b power 2. In this example, we take one of them alone and the third will be together. We will not take 3, 2 and 2. We will take 3 and 1. 16x power 2 is alone, and a power 2 minus 6ab plus 9b power 2 will factorize perfect square. Do you know perfect square? The perfect square, we know at perfect square how we find the first is perfect square and the third term is perfect square. It means 9 have square root and b power 2 have square root and a power 2 has square root. So the first and the third perfect square, and the middle will be the root of first multiply the root of third times 2. The middle is this will be find where we find the root of first a, the root of third will be 3b. Multiply a with 3b, it will be 3ab. and you must multiply 2 again. يبقى we find 6ab. So this algebraic expression is perfect square. Okay. Now we factorize perfect square bracket power 2 and take root of first, a power 2, it will be a, and root of third, it will be 3b. And the middle sign will be like the middle sign in the algebraic expression in perfect square. It's negative, we will put negative. If it's positive, we will put positive. All power 2. Okay. Again, we find the result expressions 16x power 2 minus a minus 3b all power 2 is the difference between two squares. We will factorize again. 16x power 2 will be 4x. It will be 4x and 4x. Minus will be plus and minus, or negative will be positive and negative. A minus 3b all power 2 will put it a minus 3b in first and a minus 3b in second. Then we simplify, we find the result will be 4x plus a minus 3b and 4x minus a plus 3b. Okay. Now we take the next. Sorry. Next, another example. 6x plus 3xy plus y plus 2. 6x plus 3xy plus y plus 2. We can take the first with second in one group and third with fourth another group, or the first with fourth in a group and second term with third in a group, as you like. Now we take, for example, the first with second. We take 6x plus 3xy together and y plus 2 together. We find 6x plus 3xy. The HCF between them will be, here is 6 and here is 3. We take 3. Here is x and here is x. We can take x. So the HCF will be 3x. If we take x from here, the remainder will be 6. No, it will be 2. Why? Because 6 divided 3 will be 2. Okay? 6x divided 3x is the HCF. We find 6 divided 3 is 2, and the x will deleted or removed with x. So the remainder will be 2, only 2. Plus, here is plus, and 3xy divided 3x, 3 will gone with 3, and x with x, the remainder will be y. In other term, in other bracket, y plus 2, y plus 2. There is no HCF. This is in simplest form, y plus 2. It will be y plus 2. Okay, here we find the 2 plus y and the 2 plus y. We commutative 2 and y. Why? Because the sum is commutative. It will not make any difference. Y plus 2 is like 2 plus y. So we take the common bracket, 2 plus y and 2 plus y is here. Okay? We take it. If we take this bracket from here, we find the remainder will be 3x. Here is 3x. If we take from here 2 plus y, we find the remainder is 1. Here is 1. So the factorize will be y plus 2 multiply 3x plus 1. Okay. Another example. 6x power 2 plus 3x y minus 2ax minus ay. Solution. We will take 6x power 2 plus 3xy together and negative 2ax minus ay together. Now we take HCF between 6x power 2 plus 3xy. We will find this is x and 3. We take 3. This is x power 2 and x. We take x. And we can't take y because this term hasn't any y. Okay, so we will take 3x, only 3x. If we take 3x as HCF, open bracket, we find the remainder here, 6 divided 3 equal 2. And x power 2 divided x equal x. So the remainder from 6x power 2 divided HCF is 3x, we find 2x plus 3xy divided 3x, we find 3 divided 3 equal 1 or removed, x with x removed, the remainder will be y. Then from first and second terms, if we take 3x as HCF, we find the remainder 2x plus y, 2x plus y, okay? In other terms, we take negative a as HCF in negative. Here and here, we take negative. There is a and a, we take a. And open bracket to take the remainder. Negative 2ax divided by negative a, negative with negative is positive. 2 divided 1 equal 2. A with a is gone. The remainder will be x. So if we divide to negative 2ax divided negative a, we find the remainder will be 2x. The fourth term, negative ay divided negative a, negative divided negative equal positive. A divided a equal 1 or deleted or cancelled or removed. The remainder will be y. After we take HCF from first and second, we find the bracket 2x plus y is common. Okay? We take again 2x plus y as HCF and open bracket. If we take this part or this bracket, we find the remainder will be 3x here. In other term, we take 2x plus y as HCF, we find the remainder will be negative a. So the factorize will be 2x plus y multiply 3x minus a. Example, x power 3 plus 3x power 2 plus x plus 3. We find the first with second and the third with fourth. Again, you can take the first with fourth and third, sorry. You can take first with third and second with fourth as you like. X power 3, we take here with 3x power 2 together in one group and x plus 3 in another group. Here we can take HCF. Sorry, x power 3 plus 3x power 2. We find there is no numbers. There is no numbers in HCF. Here is x power 3 and here is x power 2. We take x power 2 as HCF and open bracket. Now divide x power 3 divide x power 2. It will be x plus 3x power 2 divide x power 2. X power 2 delete with x power 2. We find the remainder is 3. Okay. So after we take HCF from these two terms, we find x plus 3 as remainder. Now here we will not take any HCF. We find the common bracket, x plus 3, and here x plus 3. We take x plus 3 as HCF again and open bracket. If we take x plus 3 from here, we find the remainder will be x power 2, but here, then plus, and x power 3, when we take it from here, we find the remainder will be 1. So the factorize of x power 3 plus 3x power 2 plus x plus 3 by grouping, we find that x plus 3 multiply x plus power 2 plus 1. Another example, 2ax plus ay plus 2bx plus by. We take 2ax with ay together and 2bx plus by together. We take from first and second a as HCF. We find the remainder 2x plus y. Here we take b. We will find the remainder 2x plus y. We find again 2x plus y as a common. We take it here, one of them. Then we find the remainder will be a plus b. Here we find 5 or 6 or 7 terms. Now we take this 6 terms example. Factorize ax power 2 minus bx power 2 plus ay power 2 minus by power 2 plus az power 2 minus bz power 2. Now, from the first and second, we take x power 2 as HCF. We find the remainder. If we take x power 2 from here and here as HCF, we find the remainder a minus b. And from third and fourth, we take y power 2 as HCF. We find a, the remainder, minus b. From fifth and sixth, we take z power 2 as HCF. We find the remainder will be a minus b. Okay? Here and here and here, we find a minus b as a common. A minus b, a minus b. We take a minus b and open bracket to take remainder. If we take a minus b from here, we find the remainder will be x power 2. Here, if we take a minus b, we find the remainder y power 2 plus طبعا. The third, if we take a minus b, we find positive z power 2 here. Then the factorize will be a minus b multiply x power 2 plus y power 2 plus z power 2. Another example. Factorize 6x power 2 plus 3x plus 20x plus 10. We take 6x power 2 plus 3x as a group and 20x plus 10 as another group. Now, in 6x power 2 plus 3x, we can take 3x as HCF. If we divide 6x power 2 divided HCF is 3x, we find the remainder. 3 divided 6 divided 3 equal to x power 2 divided x equal x. The second term, 3 divided 3 equal 1. X divided x is gone. Okay? And third and fourth, there is 20 and 10. We take 10. Then we divide it on HCF. 20x divided 10, 20 divided 10 equal 2. And x, there is no letter to divide on it. So x will be as it x. 10 divided 10 equal 1. So after we take HCF in first and the second, we find here 2x plus 1 and 2x plus 1. We take it here and HCF and open bracket. If we take 2x plus 1 from here, we find the remainder 3x. If we take 2x plus 1 here, we find the remainder 10. So the factorize for 6x power 2 plus 3x plus 20x plus 10 will be equal 3x plus 10 multiplied to x plus 1. Now I finished the explanation. There is some practice questions for you as homework. Factorize by grouping the following polynomials. Okay? I hope you enjoy and understand every example in this lesson. And with my best wishes, Mr. Muhammad Baghdad. This practice questions for you and these answers. Thank you very much. Goodbye.